Hello everybody and welcome to your very first video homework. Tuesday during class, what we are going to be doing is going over 1.3.1, which is called How Can I Classify This Shape? So your guys' objective for this class is going to be to learn how to classify shapes by their attributes using Venn diagrams. You will also review geometric vocabulary and concepts such as numbers of sides, numbers of angles, same length sides, right angles, equilateral, perimeter, parallel, all these different vocab words that you guys have probably heard before, but we're going to use a bunch of different vocab words to describe different shapes and how we can identify shapes. So that's actually the very first thing we're going to do today is going to start by reviewing some vocabulary. So these are just some vocab words that I thought we would review before going into some examples. So this should be a review for you guys, but if it is not, feel free to write them down. We are going to be going over these a lot during class. These are going to be words that we're going to be using a lot during class, not just in this section, but also throughout the entire book. So if you're like, I'm still confused or I'm not 110% comfortable with them yet, that's okay, because we're gonna use them a lot. So the very first word is a parallelogram. So a parallelogram is a four-sided plane linear figure with opposite sides parallel. So essentially what that means is it's basically a rectangle with opposite sides that are parallel. So it doesn't necessarily always have to be a rectangle, but this is one figure that it could look like. And you see that these sides are not exactly straight, but these lines are parallel. So opposite lines are parallel, and those symbols are how we state what is parallel and what is not parallel. So there's one example. You could use a square, you could use a rectangle. There's lots of different things out there where opposite sides are parallel. Then we move on to a quadrilateral. So a quadrilateral is kind of like our big umbrella. So we have this big umbrella that is quadrilateral, and then a lot of our shapes fall underneath that quadrilateral umbrella. So a quadrilateral is just a four-sided figure. So any four-sided figure at all. So we could do a weird shape like this. I'm really bad at my drawing, so I apologize, but a four-sided figure like that, again, you could do a rectangle, a square, anything with four sides. Then we move on to a trapezoid. A trapezoid is a quadrilateral with only one pair of sides parallel. So the difference between a parallelogram and a trapezoid is that the trapezoid only has one pair of sides that are parallel. So that could look something like this, and that side would be parallel. Then we move on to these three definitions, and I group those three definitions together because they're all talking about the side lengths. So the very first thing is an equilateral. So an equilateral literally has the word equal in it. So that means that all sides of the shape are equal. A lot of times we're going to use these to define triangles, but it could be used in anything. A square is an equilateral because all of the sides are the same. But if you want to, so there's my equilateral triangle. If you want to establish that sides are equal, you use this little dash symbol. So that would mean that all three sides are equal. The next one is isosceles, which means that only two sides are equal. So again, in a triangle, that might look something like that. My drawings are horrible today, so I apologize. And you could establish it using that symbol. So we are seeing that those two sides are equal, but the base is not equal to that. Then we move on to scalene, which is a shape that none of the sides have equal measures. So none of them are the same, all of them are different, so that's scalene. Then we move on to our bottom three, and I'm going to group those together because those are referring back to our angle measures. So an acute angle is an angle that has less than 90 degrees. So it is measuring less than 90 degrees. And if you have an acute triangle, all of the measures, all of the degree measures in that triangle are less than 90 degrees. A right triangle is an angle that is 90 degrees. So if you're talking about a right angle, that angle is 90 degrees. If you're talking about a right triangle, that triangle has a 90-degree angle in it. Then we go on to obtuse, which is an angle that is bigger than 90 degrees. So you are talking about only one angle in that triangle can be bigger than 90 degrees. Okay, so only one can be bigger than 90 degrees. So there is our vocab, and I'm sure we're going to go over a lot more, and if you guys have questions in class about some of the vocab, please don't be afraid to ask. So now I'm going to jump back to the book. And the first thing you guys are going to do in class tomorrow is dive into problem 110, which is an introduction to the shape bucket. So I'm going to have all of your guys' shapes cut out for you guys and ready to go, and I will show you all the shapes that you get here in a minute. But what you're going to do is you guys are going to try and make these figures with the shapes that you have in your shape bucket. So you're going to be working as a team to fill in those shapes. And then problem 111 is going to be talking about the Venn diagrams. If you need a quick refresher on Venn diagrams, I'll use this one as an example. This outside circle, the number 1 circle, if you're looking on the outside, means it only can go in that. It doesn't refer back to both parts. So if you're looking at it has at least one pair of parallel sides, if it only has one side of parallel sides, it can go in that. Then if you go over and decide number 2, it says has at least 2 sides of equal length. So if it only refers to that part, you only put it in that outside circle 2. If it refers to both part 1 and part 2, you're going to stick it in the middle portion right here. All right, so you guys are going to be working with your shape bucket again to try and fit each of those shapes into the Venn diagram. So that will be that day's lesson. And there's also another refresher in your methods and meaning sections as well. So let's jump back to our shape bucket. So these are all of the shapes that you are going to get in your bucket, and I tried to label them for you. So you guys, if you want to pause the video now, you guys can and write these down if you need that. If not, and you're like, yeah, I can get those off of definitions, you guys are completely fine. But what you guys are going to have during class is without all of the labels and the crazy writing, you guys are going to have those shapes cut out for you so you can actually move them around and use them as you need to. So those are all of the shapes that we will be using. You see an obtuse scalene triangle, which means that it has an angle that's bigger than 90 and none of the sides are equal. You have a kite, a quadrilateral, a hexagon, a rhombus, a trapezoid. Remember, a quadrilateral kind of is our parallel, or is our umbrella, so it encompasses a lot of these shapes. So just because I classified that one shape as a quadrilateral doesn't mean that there aren't other shapes in this bucket that are also quadrilaterals. You have a parallelogram down here. An acute isosceles triangle means all of the angles are less than 90, and isosceles means 2 sides are equal. Isosceles right triangle means 2 sides are equal, and it has a right angle in it. You have a square, a circle, a rectangle, hexagon, pentagon. Scalene right triangle means none of the sides are the same, but you have a right angle in it. You have your equilateral triangle. Obtuse isosceles triangle means you have an angle bigger than 90 with 2 sides that are equal. It's obviously a triangle. So if you want to write these down, you're more than welcome to. It's kind of nice to have that to reference back to, but you don't have to. You can always reference back to this video if you ever need to. So now that we are done with our vocab and our introduction lesson, I'm going to show you guys an example. So this is what's going to happen most times when we play this video, is that I will have an example ready to go for you guys, and this is actually one of your homework problems. So this is something that you would normally do for homework, but remember, we're going to cut class short about 10 minutes, and you guys are going to actually work on a homework problem. So this, you might actually see this in class just changed up a little bit. So this has to do with not only probability, but it also talks about our different shapes. So this says Sandy has a square, an equilateral triangle, a rhombus, a regular hexagon in her shape bucket. So those are all the shapes that she has. while Robert has a scalene triangle, a kite, an isosceles trapezoid, a non-special quadrilateral, and obtuse isosceles triangle in his. Sandy will randomly select a shape from her bucket, while Robert will randomly select a shape from his. So before we even dive into 1, 2, and 3, that should say a 3 there. I don't know why that doesn't. We are going to talk about what shapes Sandy has and what shapes Robert has. So starting off, it says Sandy has a square. So that one's pretty easy. We can draw a square. And if you guys want to, it would actually be a really good idea to pause this video and try this problem on your own. Never hurts to see how good you guys are doing and how well you guys can do it on your own, and then come back and follow along with us. So Sandy has a square. Then she has an equilateral triangle. So again, equilateral means all of the sides are the same. So I'm going to establish that using that. Then she has a rhombus. So that can look something like a tilted square. And so those are parallel. Then she has a hexagon. So please bear with me while I'm drawing this. There we go. Alrighty. Then Robert has a scalene triangle. So a scalene triangle means that none of the sides are equal. All right. So we are going to, I am actually, because it didn't clarify, I am going to draw that right angle that they had in your shape bucket. It's a horrible right triangle, but you get it. So there's his right triangle with none of the sides equal. Then he has a kite. Then he has an isosceles trapezoid. That is going to look something like this, where both of those are equal because isosceles means two sides are equal. Then a non-special quadrilateral. So special would mean anything that has a name. So we can't use square, we can't use rectangle. So I'm going to use that weird shape again, like that. And then an obtuse isosceles triangle means that it has a degree that's bigger than 90 and two sides are equal. So I'm just going to draw a triangle like that. We're going to assume that that angle right there is bigger than 90 and those two sides are equal to each other. All right. So Sandy has a total of 4 shapes and Robert has a total of 5 shapes. So question number 1 says, who has a greater probability of selecting a quadrilateral? Justify your conclusion. So again, quadrilateral means that it has 4 sides. Okay, so 4 sides. So Sandy has 1 and 2. That's it. Because a triangle doesn't have 4 sides and a hexagon does not have 4 sides. And then Robert has 1, 2, 3. So we have our fractions 2 over 4 for Sandy, which really equals 1/2. And for Robert, we have 3 over 5. So if you were to plug those into your calculator, get a decimal, or just do some calculations, you know that Robert would win this answer. So Robert has the greater probability for that one. Who has a greater probability of selecting an equilateral shape? So let me just erase those really quick. Alrighty. So if it is an equilateral shape, it has to be stated for us. So we cannot assume that Robert has any equilateral shapes. Even if we would have drawn that non-special equilateral with equal sides, we cannot, non-special quadrilateral, this guy, with equal sides. We can't assume that because it didn't tell us in the problem that it's an equilateral. So the only equilateral that is on this page at all is Sandy's equilateral triangle. Okay, so Sandy has a 1 out of 4 versus Robert, who has a 0 out of 5. So Sandy will win that one. And finally, what is more likely to happen? Sandy selecting a shape with at least 2 sides that are parallel, or Robert selecting a shape with at least 2 sides that are equal? So let's talk about Sandy's first. Sandy's selecting a shape with at least 2 sides that are parallel. Okay, so we know that a square has two sides that are parallel. You could either work with those ones or those ones. Triangle does not work. The rhombus does. And the hexagon has those two that are parallel, which might be a little bit trickier to see. We might not have seen that one. So Sandy has 3 out of 4. Versus Robert, who needs to be selecting a shape that has at least two sides that are equal. Again, you have to be looking for that word isosceles. Okay, it has to have that word isosceles. And the only ones that he had that stated that were his isosceles, sorry, that's a 2. His obtuse isosceles triangle and his isosceles trapezoid. So he's sitting at a 2 over 5. So that means, oh no, I apologize. The kite actually, let me revert back. The kite, based on a definition of a kite, actually has those sides that are equal. So the top part are always equal and the bottom part is always equal. And I apologize for that, but that is always stated. That is just the definition of a kite shape. So he is sitting at a 3 out of 5, but it does not matter because 3/4 is much better than 3/5. So Sandy is still going to win that one. So you guys, we went over vocabulary, we introduced the lesson, and we went over this example. So you guys should have a good foundation for what's going to happen during tomorrow's lesson. So if you guys have any questions, please let me know, and I will see you guys tomorrow in class. Have a great night.